The Aorus 5 is an entry-level gaming laptop from Gigabyte. In this detailed thermal testing, we'll find out how hot it runs, see if there's any throttling, and see what can be done to improve performance. I've got the NA version of the Aorus 5, so there's an Intel i7-9750H CPU, NVIDIA GTX 1650 graphics, 16GB of memory and dual channel, and a 144Hz 1080p screen. The GA version is also available with the GTX 1050. You can find updated prices linked in the description. Air is pulled in underneath the machine through the vents in the center, and is then exhausted out of the back and below the screen. Two heat pipes are shared between the processor and graphics. And we've got an interesting design with the two fans in the center. The fans are right below the air intakes, but the blade count of the fans is looking a little low compared to others. The Aorus Control Center software allows us to set the CPU between 5 levels of power and the GPU between 2 levels, as defined here. Throughout this testing, I've tested the stock settings with the CPU at level 2 and GPU at level 0 with the fans set to the normal profile, or with the CPU and GPU maxed out with the fans set to maximum. Unlike the higher end options like the Aorus 15, it wasn't possible to customize the fan curve. You just have the option of toggling it between normal and max speeds. There's also no shortcut on the keyboard like the higher end Aorus models to quickly swap between fan speeds. It's only done through the software. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. At idle, both the CPU and GPU were looking fine. The rest of the results are from combined CPU and GPU workloads, and are meant to represent worst case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the Aorus-64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. Whether gaming or under combined CPU and GPU stress test, the CPU was thermal throttling at 96 degrees Celsius. Basically, there's no difference, because as you'll hear later, the fans are already pretty much at max speed in normal mode due to these higher levels of heat. Although the GPU temperatures were a little warmer with an actual game running, thermal throttling on the GPU was not happening here. With the CPU undervolt applied, thermal throttling on the CPU was removed with this game running, but it was still present with the stress tests. Combining the undervolt with the cooling pad dropped temperatures the most, especially for the GPU, which dropped by 16 to 18 degrees just with this change. These are the average clock speeds for the same tests just shown. The CPU clock speeds don't change between the fans at normal and max speed, due to the thermal limitations that we just saw, though the GPU speed rose higher here with GPU mode 1, which just as a reminder overclocks the 1650 a little. The CPU undervolt makes the largest improvement to CPU clock speed, but the best results were seen when combining the cooling pad, as this lowered the temperatures substantially. CPU clock speed is improved with the stress test result as the cooling pad finally removed thermal throttling, allowing the full 4GHz all-core turbo boost speed of the 9750H to be hit. The GPU clock speeds also rise a bit, presumably as GPU boost prefers cooler temperatures. These are the TDP values during these same tests. The 50-watt limit was constantly being reached for the 1650, which is good, as shown by the green bars. Although the CPU was able to boost up to 62 watts for PL1 in CPU mode 4, we only saw 50 watts or lower prior to reducing thermal throttling with the cooling pad and undervolting, as thermals were the main limitation there. Here are the CPU clock speeds while under a CPU-only stress test. The results are higher as the GPU is not contributing heat to the system. Despite this, it was still only possible to reach the full 4.0 GHz all-core turbo boost speed of the i7-9750H CPU with some undervolting applied. This is because with CPU level 3 and 4, even in a CPU-only workload without GPU load, thermal throttling was still being hit, reducing performance. Although thermals were the limitation, if we look at the average TDP, level 4 was close to hitting its 60-watt power limit anyway. It was possible to raise the power limit through Intel XTU, but without first addressing the thermal limitation, this wouldn't help. And as we saw, undervolting got us full performance anyway with less power. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks from these same modes. Like we saw in the clock speed results previously, there's a nice jump in performance with the undervolt applied. On top of that, again as we just saw, it was also running cooler too, so the undervolt is definitely helping nicely here. So how do these different changes actually affect game performance? I've tested a couple of games to find out. Shadow of the Tomb Raider was tested with the built-in benchmark at highest settings. Like we saw in the clock speeds previously, there was no change between normal and max fan. Undervolting and using a cooling pad barely helped, improving average FPS by 1 with each. Far Cry 5 was tested with the built-in benchmark at ultra settings. Again, there wasn't really much difference between these different settings, though the 1% low was down a bit in this test at the lowest setting. Probably as it's a CPU heavy test and this is capping the max power limit. If you want to see more gaming benchmarks on this machine, check the card in the top right where I've tested 21 games at all setting levels. As for the external temperatures where you'll actually be putting your hands, at idle it was quite cool. Warmer on the right, but still below the 30 or so I usually see. With the stress tests running and fans at default speed, the right hand side of the keyboard was warmer but not too bad. Right up the back is the hottest as air exhausts below the screen. With the fan manually set to maximum, there's no change to the externals. As we saw before, internal temps were still the same, so this is to be expected, though I wouldn't call it hot, just a little warm to the touch. While gaming with the fans at max, there's not much change. The left of the wrist rest when under load was about 10 degrees cooler than the right, which was preferable as my hand sat here when on the WASD keys. Here's what the fan sounds like during these different tests. At idle, the fan was still audible. Whether gaming or under stress test, with the fan on the normal profile, it was about the same, and this hardly changed much once I manually set it to max speed. This makes sense when you consider that the CPU thermal throttling was being hit in these workloads with the normal fan profile. That said though, even with the fan at max, it is quieter than most other gaming laptops that I've tested. Overall, there was a fair bit of thermal throttling on the CPU, both under worst case stress test and while actually gaming. The CPU was averaging 96 degrees Celsius even with the fan at full speed. Although this resulted in performance loss in terms of clock speed as we saw, when actually testing out some games there appeared to be minimal practical difference. Undervolting the CPU was a good way to help boost performance, and adding a cooling pad further helped reduce temperatures by a decent amount. With these simple changes, it was possible to improve performance, but I think it would have been better if the fans had the option of going faster as more air from the cooling pad is clearly helping. The plus side of this is at least that the machine does run noticeably quieter when compared with most other gaming laptops I've tested. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements. So don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. Raising fan speed, undervolting, and using a cooling pad are much easier for most people to do than changing paste anyway. And as we've seen, these tweaks did help improve performance and temperatures with the Aorus 5. Let me know what you thought about the thermals from the Aorus 5 gaming laptop down in the comments. And if you're new to the channel, you'll definitely want to get subscribed for the upcoming full review to see everything this machine has to offer.